Okay, so for today, we'll be covering yung last part ng part 3, the Great Flood. Greenhouse today, we'll be talking about greenhouse warming, El Nino, and global climate change through time. So last part in global climate change through time, we've actually, most of the info that we've already discussed, that we'll be discussing here is review lang din nung inaral natin sa first two parts. So, para ano na lang to, additional info. So today, yung focus talaga natin will be yung more recent phenomena, which most of you must have heard already, yung greenhouse warming, greenhouse gases and global warming, and yung even more recently, just this year, Pag-asa announced na mayroong severe El Nino affecting or in place, and one of the areas that we think will be affected is of course the Philippines. Okay, so first let's again recap on weather versus climate. Again, weather is a short-term measure ng temperature, precipitation, air pressure, wind speed, direct wind speed and direction, as well as humidity in a specific area. And in terms of time frame, this is at a given time, usually within a day, within a week, kung ano yung forecast natin na conditions ng atmosphere. On the other hand, climate is the average weather conditions for a site measured over a long period of time, usually in terms of years. Both weather and climate are a function of complex series of interactions between all elements of the Earth system, mostly yung hydrosphere, cryosphere, and of course, atmosphere. So for example, yung ocean temperature natin is directly affected by the atmosphere, yung temperature din ng atmosphere. And at the same time, yung sea level, for example, is directly affected by the amount of sea ice amount of water rather, the amount of water that gets preserved as sea ice. And as we mentioned before, at least sa recent the past 2 to 5 million years ng Earth's history, the uh, the changes in sea level, it has largely been affected, controlled to a certain extent by the amount of glaciers and sea ice na present. Okay? At the same time, yung amount din ng sea ice and yung amount ng land mass, yung distribution of land mass, we've discussed before, also affects yung global climate through the effect of albedo. So, as we learned, yung albedo is the amount of sunlight that gets reflected back and therefore does not stay within the Earth. If we have too much sunlight getting reflected back to the Earth, back to the space, then we get a cooler Earth. Pero if we have less sea ice and if we have land, which is if we have more oceans than land, we have we have less sunlight that gets reflected back to the space, and at the same time, yung oceans natin which are thermal sinks basically, so they can further heat up yung planet. Okay? So all these systems are, as we've learned before, even if you take out yung biosphere, these systems are already in place. Yung lithosphere, yung atmosphere, and yung hydrosphere and cryosphere are already affecting or controlling or affecting one another and controlling yung temperature ng Earth, for example. So, ano yung recently we've been tackling or yung isa sa pinaka compelling problems that humanity is facing is global warming, of course. And we've heard this a lot, pero we just want to recap. Ano ba talaga yung trends or ano ba talaga yung is global warming real? Okay, so for the first part, we'll be looking at the trends and the possible reasons for this global warming. Okay, so global warming, what are the trends? So if we look at yung mean global surface temperature, global land ocean temperature index, it has already risen more than 1.1 degrees Celsius since pre-industrial. And in the recent the recent years have actually been among the warmest. So we've seen here pre-industrial, meaning around pre-1940s. So 1860s, around 1860s up to until 1920, we see here na relatively mababa yung temperature natin or medyo stable siya dito sa region na to of within 0 to negative 0.2 in terms of temperature anomaly. But from 1930s all the way to present, continuously on the rise lang yung global temperature sa buong mundo. And we can see that in this graph from comparing yung degree in temperature change since 1880 to 1884. And here we see na hindi equal yung distribution ng heat through time. Some regions gets heated more, yan, in some stages. Yan. So, panoorin natin. So, eventually, we see na, ayan, may periods din na relatively mas malamig. But as you can see, around 1990s, yan, halos puro orange to red na lang siya. Okay? So, kung i-replay ko lang ulit, yan. Ito, 1880s, 1890s, may areas naman mainit, pero generally, yan, kapag winter siguro, lalamig. Pero around 1930s, halos naiwan na lang siya dito sa 0 to 2 degrees Celsius. Yung sabi ko kanina 1.1, that's a global average. But as you can see in this infographic, some areas are actually experiencing hotter conditions around 2 degrees Celsius. And interesting din dito, interesting to note, yung area that gets the warmest is actually yung ating North Pole as well as itong Europe, Arabian Peninsula area. Yung North Pole is important especially kasi as we've learned from before, yung amount ng ice yung amount ng ice, glaciers and at the same time sea ice, continental ice as well as ice sheets continental ice sheets as well as yung sea ice natin, this has an effect on the albedo. So the more ice we have, especially on the poles, the more sunlight gets reflected back, and the more sunlight gets reflected back, the less heat is trapped on Earth. So if itong region na to na umiinit ngayon continues this way, we would expect less and less glaciers or less and less amount ng sea ice and continental ice sheets, and at the same time less and less sunlight gets reflected back, turning it into a feedback loop na Earth getting warmer and warmer. And that is exactly what we've been seeing since around 1940s. Okay? Yeah. So, ano yung reason na to or ano kaya yung main effect na to? For the last tectonics or the land distribution hasn't really changed that much for the last since 1880 to 2000 to present. Hindi naman nagbago yung distribution ng land masses. So, hindi natin ma-attribute yung change in temperature to change in land distribution. So it could either be, it can only be yung atmosphere natin and the amount ng glaciers natin which is affecting yung global temperature. Yung atmosphere in the sense of greenhouse gases. So as we've learned before, greenhouse gases are components sa ating atmosphere which actually trap yung heat from the solar rays. From the sun's rays, once it gets into the earth, some of that heat gets trapped by greenhouse gases, and among the greenhouse gases, of course, yung carbon dioxide. So if we compare, for example, shown here is basically a straight line from 1960 to the present, showing you an increasing trend ng carbon dioxide in the atmosphere since 1960s. But if we compare that to 1750, yung percent increase in the amount of atmospheric carbon dioxide is 150%. So this is even greater during the end of the last ice age, 20,000 years ago. So itong rapid increase na to in carbon dioxide is even greater than the end of the last ice age. So during the end of the last ice age, we experienced, as was shown, the Earth experienced a rapid increase in temperatures kasi nga yung feedback loop na less ice and then gets warmer, more sunlight gets reflected, and then gets warmer, etc., etc. But dito, yung increase natin ng carbon dioxide is even more than that. So this is from 1958 to present. It's just increasing. Mayroong mga slight dips gaya nito, and there are specific events which help contribute to those dips. Pero in general, we see this increasing trend. For example, itong period na to, yung 1990, yung slight decrease after 1990, this is related to the Pinatubo eruption, which caused global temperatures to decrease by 0.5 degrees for 2 years only. So 2 years, bumaba yung global temperatures, but still on the rise na naman yung carbon dioxide natin. And yung ating temperature is also increasing. Okay? Yan. So, this shows yung increase in carbon dioxide in the atmosphere for the last, I think this is since 2002. So medyo recent, but this is actually, ano na to, obviously this is already within this period, 2002. So nandito na tayo sa increasing. So pinapakita lang nito kung gaano kabilis nagbago or nag-increase rather yung amount ng carbon dioxide in the atmosphere during this 2002 rather to present. So from something like 365 ppm to about 435 ppm in a matter of a few decades lang. 2 decades, less than 2 decades. Okay? Yeah. So from something light, pero yung light natin, 365 na yan. So nandito yan siya nagsisimula. 365 to around 400, which is the current. Okay? Yeah. So as a consequence of this, if you get more greenhouse gases sa atmosphere and therefore more heat gets trapped within the earth, and more heat means less ice. Less ice means less reflection ng sunlight. So you get this factors essentially contributing to global warming. And yung global warming na yon has a direct effect sa level ng sea level. So, sea level, for example, has risen by 10 to 25 centimeters over the last 100 years. And this increase in sea level or this rise in sea level is not just yung direct contributions ng melting glaciers and less continental ice sheets, but it's also a function of thermal expansion. So yung ating because the the seawater is getting warmer and warmer as per this diagram. Yan. So land to ocean temperature index has been increasing, has been getting higher and higher. So yung dagat natin, yung seawater mismo, bukod sa nadadagdagan siya ng tubig, it also increases its volume as the temperature increases. Diba? So because of that, we've seen 10 to 25 centimeters per year. Why the range? Bakit 10 to 25? Kasi iba't ibang areas sa Earth experiences different sea level changes. Global to in the sense na, so, yung sinabi kong ibang areas Earth, iba rin yung sea level rise. Even looking at yung just the plain sea level, global sea level, yung sa poles natin, they generally have less increase in just because of the gravity and the shape of the Earth, yung oblate spheroid niya. So yung equators natin is farther from the center of the Earth and therefore gets less pull from the Earth's core. So yung ano ito, poles natin, they have the least amount of sea level change. Yung equator actually gets higher or gets more affected by sea level rise. Ano pa lang to, yung actual sea level. If we take into account yung local conditions, for example, kunwari, Kamanava area has been experiencing sea level rise not only because of the global change in sea level, but also because of land subsidence. So bukod sa tumataas yung tubig, yung sea level natin, yung lupa mismo bumababa siya because for example sa Kamanaba and in some areas of the globe, uh, factor yung overpumping ng groundwater. So, kung napanood niyo na yung sinend ko ngayon sa Sahara Desert, that's also one of the recent problems. In areas na kulang yung surface water, we tend to get the water that we need from groundwater. And yung effect ng pumping too much groundwater is that the soil gets compressed, and eventually compression of the soil makes the sea level basically makes the effect of sea level rise even worse. Okay? So, ito yung sea level rise due to global warming lang. Wala pa ditong effect yun nga, yung land subsidence na sinasabi ko. And as you can see this is from 1880s. Sabi ko kanina around 1920s, 1930s nagsimula yung rapid increase in sea level in land ocean temperature. And you can see almost 1:1, um, 1:1 trend together with sea level rise. So nung tumaas na yung temperature around 1930s, tumaas na din kaagad yung sea level natin, global sea level. Okay? And these are projections for the possible sea level if depending on the amount of greenhouse gas that we continue pumping throughout for the rest of the century, basically. Okay? Yan. Ito yung 1980s to 2000s. So, tingnan natin yung mas updated na values. This is the most updated values around 2019, yung last data niya. So, we've seen 10 to 25 centimeters over the last 100 years. Since 1993, it's been 96.7 millimeters. So that means 9.7, essentially 9.7 centimeters since 1993. So ganun kabilis yung increase. For you to visualize yung 9 point, if you take your height for example, 9 point na kunwari ako 170 centimeters. 170 centimeters ibig sabihin it will take roughly about just kung isarado natin tong 10. Sarado natin 10 centimeters for the last since 1993. So 10 centimeters since 1993, ngayon ay 2023 na, so 30 years. Since 30 years, 10 centimeters. So by the time na ano nga, 1.7. So by the time na mag 60 years old ako, for example, 60 years old, roughly, around 60 years old, for example, dumoble na yung amount ng sea level rise. Kung hindi mo babago tong graph na to, doble na yung sea level rise. And that means na 20 centimeters na yung naging sea level rise since 1993. So 20 centimeters, 20 centimeters is basically 2 meters. So mas mataas na siya sa height ko, for example. So malamang sa average height din. Yung average height ng Pilipino is 1.4. So basically, yung point is within our own lifetimes, yung amount ng sea level is mas matangkad sa isang tao. Ganun kabilis itong process na pinag-uusapan natin. Okay? And there is a direct correlation between the amount of sea level change and yung, as we've shown before, yung amount ng glaciers and at the same time yung amount ng greenhouse gases pumped into the atmosphere, which causes yung global warming in this particular case. Okay? So, hindi lang problem, of course, yung sea level. Climate variability or extremes in the most recent decade has also increased. So, you may have heard of the cataclysmic or catastrophic processes na nangyayari throughout the globe, yung mga extreme weather events like flooding events, yung mga droughts that is widespread sa Africa, and at the same time yung mga sa Africa as well as sa Europe, droughts yung pinaka-problem doon. Dito naman sa South Asia together with the Southeast Asia. Mixed scenario siya ng flooding and at the same time droughts. Tapos sa Northern Hemisphere naman, yung main problem natin is drier and drier summers, which leads to more and more wildfires and therefore further destruction ng ecosystems. And so we've seen before, yung increase in greenhouse gases can explain or resulting from human activities such as deforestation, burning of fossil fuels, as well as agriculture actually is one of the main contributor ng greenhouse gases. You can think of it as yung utot ng poultry, ng livestock na just because of that, yung methane na ini-emit nun is actually another greenhouse gas that contributes to the warming of the globe. Greenhouse gases is a gas in the atmosphere that of course, as I've said before, absorbs yung sunlight and traps yung heat from the sunlight, producing yung ating tinatawag na greenhouse effect. Sa Earth, yung primary greenhouse gases natin is water vapor, carbon dioxide, methane, nitrous oxide, and ozone. Of this, yung pinaka malilink natin or directly rather na malilink natin to human activities would be these two, the increasing carbon dioxide as well as increasing methane contribution to the atmosphere. If wala yung human activity, for example, greenhouse gases and global temperatures also increases every now and then. But as you can see from here, pre-industrial period, as soon as tumaas siya, there are other processes which smoothens it out, which causes the abrupt change then towards cooler temperatures. If we are to leave the conditions or if we are to leave it by itself. Kunwari, nung pumatok sa pinatubo, bumaba yung temperature ng 0.5 degrees Celsius, but then nung wala na yung ash covering the stratosphere and reflecting the sunlight, nag-rebound na rin kagad yung temperature sa Earth. So there are natural processes which balances things out. Pero yung main concern natin this time is the very rapid increase in the amount of greenhouse gases in the atmosphere so that hindi na nakaka-keep up yung ating natural balancing ng planet natin. Okay? Yeah. So, this greatly affects yung currently, ito yung biggest factor affecting yung temperature sa Earth. And without them, the Earth's surface will be on average around 32 degrees Celsius colder than at present. Okay. So, this is the main greenhouse gases and yung kanilang global warming potential. Take note na although we always talk about greenhouse gases, about carbon dioxide being the most voluminous in terms of greenhouse gas, actually another potent greenhouse gas with a global warming potential of 21 times carbon dioxide is methane. Although the volume is much less, it's actually more potent in warming yung Earth natin. And yung main contributor nitong methane gas nito is actually agriculture, livestock, for example. Right? Yan. So, ito yung just to illustrate yung paano nag-work or paano nakaka-affect yung greenhouse gas. Yung sunlight natin, usually some of the sunlight gets reflected back. Solar radiation is around 343 watts per square meter. Pero if we have greenhouse gases, we decrease yung amount ng outgoing infrared radiations to around 240 watts per square meter. So some of the solar radiation, of course, it gets reflected back, but yung absorption ng ating solar radiation is around 168 watts per square meter because of the effect ng greenhouse gases. Yan. So, ito yung 343 yung starting natin. Some gets reflected back. So, usually in average around 240 yung naiiwan. And of that 240, yung 168 yung ating nare-retain. And although, of course, hindi rin naman natin gusto na sobrang baba nitong value na nare-retain kasi that would be a very cool Earth, very cold naman na Earth. We just don't, well, we need this value to go back to pre-industrial levels. Okay? Yeah. So, yung increase na yon, the greenhouse effect is largely due to increase in carbon dioxide and methane in the air, and atmospheric carbon dioxide, which has increased from pre-industrial, is thought to cause yung rapid increase in the in the global temperature. So, for example, if you look at this plot, fossil fuel emissions in atmospheric concentration units, we see this continuous increase in carbon dioxide in terms of annual change. So, yeah, since 1870s. So although this is already an industrial world, nag-boom yung industrialization around 1940s, and from there, since then, nag-took off na lang yung carbon dioxide sa buong mundo. And ito yung important. During this period, if you look at the map, yung kung sino yung nag-burn ng fossil fuel to run yung industries natin, since in the past, yung nag-burn ng fossil fuels are actually yung areas na to, so Asia, North and Central America, as well as Europe. Eventually, once the areas have been industrialized, hindi na sila yung nagpo-produce ng carbon dioxide, and it's now the areas na nagsisimula pala mag-industrialize like South America, Africa, and Asia that is now contributing more sa carbon dioxide emissions. So this is a problem in the sense that as it seems, yung modern civilization or modern industrialized civilization apparently is built on the carbon emissions, basically. And if you look at other gases, nitrogen and methane, parehas yung trend since if we these are graphs calculated before 2005. So within 0 to around this is 5,000, so 2,500. Anyway, in the last century or so, and 1800s pala. In the last century or so, we saw this very rapid increase in amount of nitrous oxide and methane, which are, although less in abundance compared to carbon dioxide, has actually worse or has a more potent effect sa trapping ng heat. So if there's warming, so what? Aside from sea level rise, we've seen before, it can actually affect yung health, agriculture, forests, water resource, coastal areas, species, and natural areas, and natural air. For example, one direct effect of warming Earth, yung rising temperature is of course sa tropics or sa typhoon belt, for example, one direct effect is stronger and stronger typhoons. So the idea is that the warmer seas provides more fuel, as we will see later, provides more fuel for stronger typhoons, stronger and more heavy or more rainfall heavy typhoons. At the same time, in dry areas naman, yung warmer and usually drier extreme climates results to more cases ng wildfires that are spreading uncontrollably because of the drier climate. Yeah. And as a whole, yung change in the global temperature affects also, of course, yung water distribution as a whole, saan uulan, saan yung dating malakas yung dating periods or dating regions that is affected by monsoon rains can can change basically because of the changing climate. Yeah. Right. So climate models calculate that the global mean surface temperature could rise around about 1 to 4.5 centigrade by 2100 by 2100. And increase in climate variability, the great weather and flood catastrophes over the last 40 years. Mamaya magko-concentrate tayo sa Philippines, pero we see that Philippines is actually among the areas that is at most risk in this changing climate. So for example, in terms of mountain regions, yung effective climate in the area with a plus 3.5 degrees Celsius and plus 10% precipitation change scenario, yung amount or yung climate, yung effective climate dun sa region natin ng bundok also changes. So yung amount hindi pala amount, yung type ng habitats na available for organisms, for ecosystems na used to living in a cool environment also changes. And hindi ko na masyado na-discuss kanina, yung carbon dioxide, it has, aside from warming yung earth, it also has another effect. So rising carbon dioxide or increasing amounts of carbon dioxide in the atmosphere also results to ocean acidification. So yung natural sink ng carbon dioxide natin, even if we don't do anything, yung carbon dioxide, kunwari, mag-stop tayo ng carbon emissions. If we stop carbon emissions today, just because, yung carbon dioxide na yan will eventually sink or will eventually be absorbed by the seawater as well as the rocks. Okay? Pero at the rate that we are doing it, yung rapid increase in carbon dioxide forces yung dagat to absorb more carbon dioxide, and this in turn results to the ocean water being more and more acidic. Nagiging carbonic acid na siya. Okay? And it has an effect on not only on this process has an effect not only on the ecosystems sa land, but also ecosystems at sea. So, yung more acidic ocean water causes breakdown for the mostly carbonate marine organisms. So yung mga reef builders natin, most of the shells that they have are actually carbonates, and they are very unstable kapag acidic yung tubig. So it breaks down yung producers sa marine ecosystem, and if you think it through, siyempre mag-breakdown yung ecosystem. Hindi man na siya mag-breakdown or kailangan mag-readjust ng ecosystem. Yan. So hindi lang siya sa amount ng rainfall, but also the water resource. So the changing pattern ng ulan also affects yung water resource, yung distribution ng water resource natin. Yan. So climate models calculate that melting of small glaciers and polar ice caps may lead to sea level rise of around 0.5 meters. However, if we melt in Greenland ice sheet, it can result to an increase of 7.2 meters of sea level. And if the Antarctic sea ice is molten, about 61 meters of sea level rise. So, of course, that is a direct contribution ng volume of water into the sea, but at the same time, yung warming seawater also causes it to expand, and therefore for this overall sea level to increase. Yan. As we've mentioned before, there are, of course, natural causes. As we've seen in the past, there are natural causes for the changing climate. One is, of course, in distribution of land, plate tectonics. Plate tectonics, so yung distribution of land, which affects yung albedo, which will be tackled more later. And at the same time, yung natural sources of greenhouse gases natin. Volcanoes are, of course, contributors ng greenhouse ng carbon dioxide into the atmosphere. And if you have prolonged volcanism that can put too much carbon dioxide also in the atmosphere, therefore resulting to um, a uh, warmer climate. But that's not the case in this particular reason. Yung second possible is solar output and variations in solar output. We can also measure this one, and we know that this is not the case. Ocean variability, yung distribution ng heat is also, of course, a function of um, the distribution ng heat via sea through the sea. So yan yung ocean currents natin. But we also know that this is a function of distribution ng land masses, which hasn't changed for the better part of the last 2 centuries. Ganun din yung orbital variations, which we've learned before, yung Milankovitch cycles. And these are natural variations in the shape of the orbit and the shape of rotation of Earth, which directly affects yung global climate. But all in all, we know that all these processes, natural processes, while possible, is not the one to blame directly for the not for the most recent rapid increase in um, global climate. So for example, in plate tectonics and climate, since ocean and atmosphere circulation are linked, any process that changes one forces the other, consequently affecting yung climate. So for example, yung landmass distribution natin, i-forward ko lang dito. So ito yung Earth natin na example. Since ito yung shape niya and the amount of sunlight or the sunlight goes like this, yung area that gets the most amount ng sunlight is actually by surface area is actually yung ating equators. Yung poles natin, although it has uh, more land, if it has land dun sa poles natin, then yung amount ng sunlight that gets reflected back is actually less than if yung land natin ay nasa gitna. So, sabi natin before, yung ocean is the sink for heat from the sun, and yung land natin is actually the one that reflects it. So, if yung land natin is nakadistribute dito sa center, near the equator, where most sunlight is supplied by the sun, then we get more light reflected back to space. Pero kapag yung land mass natin ay nasa poles, then less sunlight gets reflected back to space. And itong scenario na to leads to more solar radiation, therefore warmer and warmer climate. Ito namang land yung nasa gitna produces cooler Earth kasi more sunlight is reflected back towards the space. So this is one concrete control ng albedo ng Earth, pero we know na hindi naman nagbago yung land distribution for the last 2 centuries essentially. Yan, amount ng volcanism. As we've seen before, kapag some episodes of intense volcanism can also contribute to drastic increase in temperature of the Earth because of the greenhouse gases that it puts into the atmosphere, and itong greenhouse gas na to again results to warmer Earth. Yeah. For example, if you look at yung Earth's geologic climate through time, for example, during the late Paleozoic, yung continents natin were mostly bunched up near the South Pole, yung Gondwana land, and this resulted to a cool Earth. Malamig yung global temperature natin, about 12 degrees Celsius. Ngayon tayo ay nasa ano yan siya. Hindi kita masyado dito, pero tayo ay nasa cool Earth that time, during the late Paleozoic. Ngayon naman, during the Middle Cretaceous naman, on the other hand, walang Atlantic Ocean. Australia is attached to Antarctica, no polar ice in either hemispheres, and plant and animal fossils pole are present 15 degrees latitude poleward, and the carbon dioxide was 400 to 600% of present concentration. So much, way more than what we have now. And because of this, we have a very long period of a warm climate. So during the period of dinosaurs, for example, it was a warm Earth environment. Yeah. So these are changes, like climate changes, directly or caused by natural processes. And as we've seen before, in terms of the Earth, in terms of the more recent history ng Earth, 5 million years, yung pinaka nagko-control naman ng climate natin ngayon, since generally hindi naman nagbago in the last 5 million years yung land distribution, um, hindi rin nagbago yung amount ng volcanism, at least based sa current natin na knowledge. So, ano kaya yung nagko-control ng climate recently? In the yung natural factor that has been controlling yung Earth's climate for the last 5 million years, as we've learned before, is yung Milankovitch cycles nga. So, at present though, is the Earth really warming? I think I've shown this before na if we look at only yung ground-based and ocean surface sensors up until 1997, we can see here na basically mukhang bumababa yung temperature ng buong mundo up to 1997. Pero if you look at yung, ayan, ito yung pinapakita niya, bumababa yung temperature, kita naman dito. But this is around 1997. If you look at the graph since then, around 1997, and ito yan siya, since then, nag-increase lang lalo yung temperature natin. And even if we look at yung 100 150 years na average natin, yung red line, we can still see na it's basically increasing since for the last 150 years. So increasing lang siya by about 0.045 per decade. If it's the more recent that we are looking at, mas steep siya, of course. If, for example, for the last 25 years, it's been increasing like at the rate of 0.177 degrees Celsius per decade. So medyo malaki yung mabilis basically the point is that if we look at depende kung sino yung tatanungin mo, I mean, kung anong period yung titingnan mo, pwede mong sabihin na, pwede mo siyang i-frame na wala namang climate change, the global temperature is actually decreasing, and yun yung nating tinitingnan. But actually, present, since 1997, the global temperature has just been increasing, like so. And as we mentioned before, the last decade has been among the warmest in the recent history. Yan. So sea ice formation is predicted to be decreasing if we look at yung annual. But of course, if you look at yung year on year, pwede mong sabihin na bakit itong particular month na to, marami namang sea ice. Itong particular month na to, wala. Depende syempre sa seasons. And at the same time, year on year, pwedeng hindi naman siya always warmer and warmer winters. Some winters are actually much colder, but again, the overall trend is increasing temperature average annually. Ayan. Ayan. So, hindi naman tatanggi, basically, na we have an increasing trend, global temperature trend for the last decade, and for the last decades pala. And yung distribution ng temperature na to is not also equal throughout the globe. Some areas, for example, in sa northern hemisphere nga, this is Philippines. Here we have Philippines. You can see also na yung global temperature here is much higher compared to other areas. In some areas like Western United States, it's actually decreasing. Yan, mukha siyang, I mean, the percent change in temperature is actually decreasing per decade. Pero for the most part, yan, tumataas lang yung temperature. Yan. And as a function of this, yung ating amount ng continental ice sheets and sea ice are basically decreasing. So here we have um, increasing yung red, decreasing yung blue colors, and we see more and more from no change, which is green, from areas na no change, green. We see more and more shades of blue, and yeah, we see more shades of blues and violets, which shows decreasing amount of sea ice. Okay? And take note, this is not the most up-to-date info. This is 2003. If you've been following the news, you will learn that actually hindi na ganito yung shape ng Antarctica. Some of this ice, some of the sea ice have already melted actually. Ayan. And as a function of that, bukod sa sea level rise, bukod sa global temperature increase and glacier melting, we also have, as a function of that, we have um, sea level, global increase in sea level. So, hindi siya straight line din kasi meron kang may mga processes which decrease yung amount ng supply ng fresh water that goes into the sea. For example, noticeable to from 1960s to around early 2000s, there was a slowdown in the sea level rise, and hindi to dahil bumaba yung temperature or anything. This is more of global dam project. So of course, as more people build bigger and bigger dams, less surface water reaches the sea, and therefore yung sea level natin does not increase that much. Pero eventually, as you can see, nag-catch up lang din yung environment, yung ano natin, yung sea level natin because of the because of the temperature rise. So 19th to 20th century, it's around 1 it's about 17 centimeters yung change natin. So isang height na yun ng tao, 0.17 of a meter per year, I think. Ngayon, 1.8 millimeters per year na. So, medyo mabilis. Ayan. And yung Arctic temperature and sea ice natin, Arctic Antarctica, both in the South Pole, Antarctica, and in the North Pole, Arctic or Greenland, we see this continuous trend. Mas mabilis sa north kaysa sa south, pero both are decreasing. Rate of change is 273 billion metric tons per year since 2002 for Greenland. So super fast, basically. And if you look at Antarctica, it's much lower, 151 billion metric tons per year lang, a decrease, pero it's still going the same trend, decreasing. So as a direct effect of that, less and less ice, a warmer and warmer climate, the Earth, yung Earth system natin, atmosphere, hydrosphere, cryosphere, are having to rebalance yung processes. And rebalancing means more extreme weather conditions. Extreme weather conditions, extreme in the sense of humans. So we see these stronger typhoons, stronger hurricanes, more heat waves, and more blizzards. If you've been following the news last year, yung summer last year, it was one of the worst for Europe. You must have seen a lot of ancient sites now buried beneath once buried beneath rivers. Pero na-expose sila last year summer. Mga holy sites, for example, sa Spain, China. Sorry, hindi ko nalagdag dito, but yeah, if you Google back yung mga news last year, most of those were like that. Drought, yung effects ng that is another extreme weather event. Yeah. In terms of this is trend in annual precipitation, we see an increasing trend in the northern hemisphere, yeah, and decreasing trend for the southern hemisphere. So ito yung sinasabi ko na hindi naman necessarily less rains, pero kailangan because of the changing conditions, the Earth system is having to reinvent itself kung saan, for example, the distribution of rain is now changing with it increasing in the northern hemisphere compared to the southern hemisphere. How about in the Philippines? A recent report published just 2021 by the German Global Climate Risk Index, you can see that among number in the Philippines is number 4 in the number of countries that is most affected ng extreme weather events from 2000 to 2019. And although mukhang magandang tingnan na in terms of fatalities, it's much less for us compared to the other countries, and in terms of losses in GDP unit uh, in percentage, it's much less also for us compared to the rest of the globe. It still poses a threat because it clearly shows na um, in the if you look at the list of countries, these are basically developed. These are all developing countries, and we are the ones that are most at risk to extreme or to the global climate change, global warming, and increasing effects of climate change. Yeah, so dito tayo sa region that has been affected. 2000 to 2019 tayo yung largely affected by extreme weather events. Bukod sa Pilipinas, you can see here, for example, Pakistan, which just a few years ago has experienced extreme events, extreme flooding events rather, which claimed a few hundreds, I think it's just a little less than 1,000 lives yung claim ng flooding event na yun. Of course, yung Pilipinas din. So, and yung sinasabi ko nga kanina, sa Pilipinas, it's predicted to have, Pag-asa has predicted na we may have less typhoons because of this, as an effect of the climate change. But this less typhoons is not really good news kasi we have less typhoons, but they are expected to be stronger kasi yung warmer sea water natin actually brings more or actually provides more fuel for storms. Okay? In some areas, kung sa atin mas less, in some areas naman, meron ding kabaliktaran naman yung effect, more and more severe tropical cyclones. Yeah. And in the case of Philippines, yung stronger typhoons is expected to bring more rainfall, and the faster winds will, of course, whip higher and more intense storm surges, which directly affects yung coastal communities. Yan. So paano ba nag-work yung storm, and bakit kapag uminit yung seawater ay we also expect that storms to be stronger? And if we read this, basically the point is that the warmer air here, once it rises, diba, cool air goes down, warm air goes up in terms of a cycle, therefore producing eventually a cycle like so. So dito natin makita na the warmer yung surface temperature natin, the more drastic yung difference between the surface and the troposphere. And because of that, yung extreme gradient na yun provides more fuel for this for storms to be made. So yeah, vast amounts of water evaporate, humid air ascends, and eventually spinning around an eye, which sucks in more warm air, and then cool dito sa surface, more warm air, cooled sa surface, etc., etc. Kapag yung surface temperature natin is very high, then you have more and more warm air that can fuel itong typhoon natin. Of course, eventually, kapag yung typhoon natin hits yung land, wala na siyang seawater, wala na siyang water, wala na siyang warm water rather, na can add fuel to it. So eventually, nagda-die off yung typhoons. Pero imagine if for example, kayo yung sa summer, east of Samar, Philippine Sea, tapos yung Pacific Ocean, where much of the typhoons are born, doon yung makikita yung, so basically what you're expecting is warmer and warmer seas, and therefore stronger and stronger typhoons. which could basically hit the same area year on year. And yun actually yung ang net effect niya is of course bukod sa loss of life, loss of GDP. Yan. Farmlands na lagi nasisira, parang ganon. So if we look at yung frequency din ng rainfall range, we see that we see this distinct spike so that more and more 2004 is light green, dark green in 2010. Yung indication, yung pino-point out dito is that more and more years record um, uh, a range ng rainfall of around 100 millimeters per year. Ayan. So for example, more and more events with more than 100 millimeters per year. So for example, this is 2012, comparing yung Ondoy, Habagat 2012, and Maring plus Habagat. Yung dash lines represents yung average monthly rainfall during August. And as you can see, in all three areas, they record much higher rainfall in these two events lang, 4-day period at saka 3-day period, basically compressed. Basically yung average ng isang buwan, nako-compress siya in a 3-day to 4-day event, which of course will have an effect dun sa flooding in the area. And then, aside from the flooding in the area, because mas marami kang water, yung warmer warmer seas natin and higher sea level whips up stronger and stronger typhoons then. So ito sa Yolanda, for example, November 8, 2013, ito yung itsura niya. Tapos, take note ng isa pang bagyo dito actually that time, nakakatapos lang, tapos may bago na naman. So, nadi-dissolve pa lang yung isa, mayroon na naman kapalit. Dito. Okay. So, this year, Pag-asa has already declared na may El Nino that is in effect. And itong El Nino is another extreme event. This time, El Nino is a natural cycle. Hindi naman siya directly linked lang. It cannot be directly linked sa climate change. Pero yung effects ng climate change compounded by the effects of El Nino is something to be worried about. So today, for the last part, we'll learn kung ano ba yung El Nino in the first place. Right? So ito yung kanina kong in-explain na yung amount ng ating, ano ba yung nagko-control ng distribution ng heat sa Earth. So since yung Earth is slightly tilted like so, yung amount ng sunlight that gets reflected sa equator is actually more than kung ano yung natatanggap ng nasa poles. So it's at an angle sa poles, pero it's direct hit basically sa equators. And because of that, you have cooler poles and warmer equator. So this drives yung atmospheric circulation. You have what we call the Hadley cell. So yung heat natin is redistributed from the hot area sa equator towards the cooler poles, producing these cells. Pero this Hadley cell is further complicated by the Coriolis effect. Ang Coriolis effect is basically if the Earth was not moving, straightforward lang yung distribution ng heat from north to south. Ganyan lang siya. Pero since the Earth is moving, yung north to south na movement na yun, or rather north to equator and south pole to equator na movement na yun, actually becomes at an angle. Okay? So, in the end, what you have is actually movement like so. So, from the north or from the poles, papunta sa equator, it moves clockwise and then clockwise south naman yun sila. So, clockwise, and then dito, clockwise din. And basically, what you have is, ito yung, instead of having such a simple Hadley cell, what you have are multiple cells, basically, affected by multiple Hadley cells affected by Coriolis effect. So, meaning siya. Okay, and you also have, because of this, you also have different wind systems. For example, yung trade winds, which is a main factor or is a main driving force for El Nino. So the Hadley cell, this is where you have warm air converging on the equator and then rising, forming a belt of low pressure. And itong belt of low pressure na to actually produces yung ating storms. So, itong low pressure area na to, dito sa, as the warm air goes up, itong low pressure na to, pulls in more warm air dito and eventually yun yung nagiging typhoons natin. In typhoons sa north, cyclones, and also tropical storms, these are all the same thing. Basically concentrations ng high speed moving wind na depende lang kung saang region nagbabago-bago yung naming niya. Okay? Sa Northern Hemisphere, yung typhoon na tawag natin, sa northern Atlantic, it's called the cyclone. Sa Southern Hemisphere, it's called the tropical storm, but it's essentially the same process. You have a low pressure, and then that low pressure sucks in yung warm air natin, which produces yung ating storms. Okay? So warm air converges on the equator and rises, forming a belt of low pressure, and the humidity of the air increases as it cools down during the ascent, causing condensation and cloud formation. So ang cloud formation na to, ito yung eventually mag-bring or yung magdadala ng ating rainfall or rainwater. Okay? Feral cells, on the other hand, are the mid-latitude. So kung ito yung Hadley, ito naman yung feral dito sa Northern Hemisphere and the Southern Hemisphere. Circulation in these cells results from the air flowing towards the poles from the subtropical side, which collides with cold air flowing from the poles. Yan. Resulting also to cloud formation. And then lastly, yung polar cells, which are basically cold, dense air, ascending in polar high pressure systems and moving towards the equator. So, and yung green, ito, tsaka ito. Okay? Okay. So, yung different cells na yon, of course, controls yung ating, so imagine if you have a cup of water and if you blow to the surface ng tubig na yon, you make waves, di ba? If you try it out, it will make waves. And yung waves na ginawa ninyo by blowing through that water is basically the process that controls also yung ocean circulation natin. So yung ocean circulation natin, yung circulation ng water in the oceans is primarily driven by the winds, roughly following yung global wind pattern. Although it's of course also affected by the Coriolis effect, again, yung movement, yung rotation of Earth. So it's, for example, clockwise in the Northern Hemisphere and counterclockwise in the Southern Hemisphere. Plus yung geostrophic movement of the geostrophic movement, which is the horizontal movement of surface water. So side to side lang siya. So yung dalawang factors na yon controls yung final direction or final direction ng ating water. Okay? This also drives yung temperature gradient sa atmosphere from the south and sa north, also drives yung ating deep water circulation. So yung mamaya maririnig nyo ito, yung thermohaline or density-driven deep water currents, which is a function of temperature and salinity. So parang air lang, density difference causes the cold water to sink and the warm water to rise to their appropriate density levels. And yung global distribution ng heat sa water is actually, or sa oceans, is driven by this deep water circulation. So ano naman yung ENSO, El Nino Southern Oscillation? So, although dito, kita natin itong um, ocean deep water circulation, yung ENSO is this equatorial, south equatorial currents, is mainly concerned with this south and north equatorial currents. Okay, so ENSO is El Nino Southern Oscillation. So ano ibig sabihin ng El Nino? El Nino is actually the term given to it by Peruvian fishermen who experienced na during some periods na pag mas mainit yung dagat, yung seawater, or there are periods na the seawater hindi pala mas cooler. There are periods sa Peru na mas mainit yung seawater, mas malamig yung seawater nila. And this actually brings in more bountiful catch. Yeah, more bountiful catch. May makita niyo kung bakit. More bountiful catch ng fishes. But at the same time, sa other end naman ng globe, sa other end ng Pacific, it has an opposite effect. So itong period na to, which is quasi-periodic, meaning it's not really periodic, hindi siya regular in terms of periodicity, pero it happens to plus minus, kumbaga. So kaya siya tinatawag na quasi-periodic climate pattern. Yung Peruvian fisherman, kilala siya as El Nino or the Baby Jesus actually. Yung climate scientist naman, ang tawag sa kanya ay Southern Oscillation. So, minerge yung dalawang names, it became ENSO or El Nino Southern Oscillation. So, usually, ikwento in simple terms, yeah. So, tingnan na lang natin yung nangyayari, normal condition versus El Nino condition. So non-El Nino conditions. So non-El Nino conditions, yung ating surface air, yung ating atmospheric circulation pala, specifically yung trade winds natin. Yung trade winds natin pushes yung warm air from this area, it pushes it papunta dito sa sa Western Australia, papunta sa Pilipinas. So yeah, punta siya dito. And because of this push, push by the strong trade winds, yung surface natin, warm water gets pushed here. So yung cold water sa ilalim rises. Okay? So yung thermohaline natin rises. That cool water brings in more fishes, more nutrient-rich cool waters, which brings yung bountiful fisheries dito sa Peruvian coast. During El Nino, sorry, baliktad pala yung sinabi ko nila. During El Nino, baliktad yun nangyayari. Yung trade winds natin is weak so that it does not drive yung warm water papunta sa Australia. Instead, the warm water stays here in the middle of the Pacific or even gets pushed back papunta sa Peru, and this weakens yung thermohaline. So wala nang enough push papunta dito so that the thermohaline decreases, the cold water stays at the bottom, therefore no fishes. No, not much fishes. Okay? So yun yung effect ng El Nino Southern Oscillation. Although we think of it in terms of circulation ng water, it has direct effects, of course, sa atmospheric conditions then. For example, during the during the worst El Nino season, yung season na yon, El Nino season, brought excessive rainfall in some areas of the globe. For example, wetter than average winters in the northern hemisphere, but at the same time, drier than average periods sa Australia, sa Indonesia, and in the Philippines. Yeah. So, yun yung El Nino. And eventually, yung El Nino stops in the sense that the trade winds eventually comes back, mag-increase, lalakas ulit yung trade winds, and therefore, Pag lumakas na ulit yung trade winds, mapupush niya na ulit yung warm water and we go back to the normal non-El Nino condition. But on the way there, usually yung another effect naman ay yung tinatawag na La Nina. La Nina is characterized naman by low air surface pressure sa Western Pacific. So ito yung two sides of the same coin, El Nino and La Nina, pero meron ka pang third condition which is yung normal condition lang, non-El Nino condition. This one. Yan. Uh, Sige, panoorin na natin ito. Ito mas, isi-send ko na lang yung link nitong video na to para mapanood nyo rin siya at your own time. Pero this is a 12-minute video which explains yung El Nino in more detail and it's yung global effect niya. Okay? Para meron kayong perspective kung ano yung nangyayari kapag El Nino season. Yeah. So, sa Pilipinas, in the recent uh, weeks actually, nag-issue na yung pag-asa ng uh, ENSO, ng ENSO alert, El Nino alert, and the probability of it is very high. Yeah. A transition from ENSO neutral to El Nino is favored during May to July 2023, with chances of El Nino increasing through the fall and early winter of 2023 to 2024. Fall will be around October, November, and then early winter is December 2023 to 2024. So El Nino alert is issued. And this is issued when conditions are favorable with 70% chance or more of El Nino developing within the next 2 months. Yan. I-play ko na lang yung video pero panoorin nyo rin siya at your own time. Play. So, hindi ko lang na-realize kung naka-share ba. Shit, hindi nga naka-share yun sa akin. Anyway, i-play ko na lang isa-send ko na lang yung link ng video para mapanood niyo ulit yung video tungkol sa ENSO. So please watch that. It's a comprehensive, just a 12-minute video by The Economist. It's a very informative primer on what El Nino is. Okay, so that's it for this lecture. Tapos na tayo sa chapter 3. Next week, we move on to the last part ng Geol 1, yung um, last part ng Geol 1, which is living dangerously. Okay, so we'll have a quiz on Thursday again on the lecture before plus yung on the Milankovitch cycles and yung video naman on the Sahara Desert. Okay, thank you.